Camera Geometry Box. We are working with demo versions of VideoCAD 8 Lite. Click on the Camera Geometry button. The Camera Geometry box with geometric parameters of the active camera and its view area appears. If you move the cursor over the box with any parameter, the name of the parameter in this box will appear. For detailed information on any parameter, click the box with this parameter and press F1. For demonstration of camera parameters, we place several 3D models in horizontal and vertical projections. And open the 3D window. Let's return to the parameters in the Camera Geometry box. Lens focal length, image sensor size, and aspect ratio are the most important camera parameters from which the view angles are calculated in the program, horizontal and vertical. The accuracy of the view angles determines the accuracy of the camera simulation. The calculated view angles can be seen in the pop-up hint. You can select parameter values from the list or type from the keyboard. It is convenient to scroll through the values by rotating the mouse wheel. The more the lens focal length is, the smaller the camera view angles. The lens focal length box is duplicated on the toolbar for permanent access. The image sensor size also affects the view angles. The smaller the image sensor size is, the smaller the camera view angles. The image sensor size can be specified through its format and in other ways. The aspect ratio is the ratio of the horizontal size of the image on the camera output to its vertical size. You can set this ratio arbitrarily by selecting values from the list or by typing. For simple cameras, or when an error of up to 20% is acceptable, you can just copy the values of focal length, image sensor size, and aspect ratio from the camera specification. For modern cameras and high requirements for accuracy, you need to better understand these parameters. You can find detailed information in the Help system. Select the box with the parameter and press F1. The plus button opens the sensor and lens box, which allows you to set the lens and image sensor parameters more accurately. Here, you can also set position of panoramic camera. Now, we are not going deep into the details and just set the parameters according to the specification of the camera and the lens. Below are the geometric parameters of the camera installation, the meaning of which is clear from the camera position scheme in the box. First of all, you need to set height limits of the view area projection. The heights of lower and upper bounds of the view area determine the minimum and maximum heights of the target. We talked in detail about the view area and the rules of calculating its projection in the video Camera View Area. Height of view area lower bound limits the projection of view area from below. Height of view area upper bound limits the projection of the view area from above. The height of view area upper bound also determines the optimal tilt of the camera. If a box turns red, then a value in the box is incorrect. In this case, the height of view area upper bound is less than the height of view area lower bound, but the lower bound must be lower than the upper bound. For example, if we are interested in surveillance over people who are not trying to hide from the surveillance, it is sufficient to set the height of view area lower bound equals 1 meter, and the height of upper bound equals 2 meters. If it is possible to cross the monitored area by crawling, the lower bound must be lowered to 0. If we surveillance over trucks, then the height of upper bound must be raised to the height of the trucks. Let's undo last operations. Next, we must set the height of camera installation. As well as the bounds of view area projection, the height can be set in a wide range. The height can be negative. Then the camera will look from the bottom up. We can hide the floor surface. Pay attention to the changes of the camera installation scheme in the camera geometry box, depending on the parameter values. The last parameter to consider is the distance to the upper bound of the view area. In this camera position, the distance determines the maximum viewing distance. The distance can also be positive and negative. In other camera positions, this distance may mean another, but its meaning is always clear from the scheme in the camera geometry box. For example, in this position, the distance determines the distance to the near bound of the view area projection, that is, the dead zone. The distance to the view area upper bound will be changed automatically while editing the camera on the layout. It is not necessary to set it in the camera geometry box. It is very important that the camera installation height, view area upper bound height, and view area upper bound distance determine the tilt angle of the camera. In this case, the obtained tilt is optimal for the given maximums of target height and surveillance distance. Editing the tilt of the camera should be primarily performed through changing this distance by moving grips on the corners of the view area projection on the layout. The limits of the view area in height are determined by heights of possible targets. It is not recommended to change them unnecessarily. The parameters at the bottom of the box are obtained from calculation, dimensions of the view area horizontal projection that we see on the layout. Using the maximum distance of drawing view area, we can make it so that the view area is not drawn beyond the specified distance. This may be required in case of too long or infinite view area. The projection switch changes the calculation rule for the view area projection. Leave it marked. Before that, we worked with the demo version of VideoCAD 8 Lite. In VideoCAD Professional version, the camera geometry box contains additional parameters. Angle of rotation of the camera around its axis. The rotation allows you to set camera position more accurately. The base height is used when working with multi-level constructions, for example, with multi-story buildings. Unlike the height of camera installation, when the base height is increased, the camera rises together with the bounds of its view area. The view area bounds are set relative to the base height. The camera tilt angle is not changed when the base height is changed. In other words, the camera rises or lowers with its ground. For comparison, changing the height of camera installation changes the camera tilt. In the sensor and lens box, it is possible to model the lens distortion. Often, the values of the view angles obtained as a result of calculation differ from the angles in the camera specification. To accurately simulate such cameras, it is necessary to model the lens distortion. We regularly transfer tools from the professional version to the light version so it is possible that some of these tools are already available in the current version of VideoCAD Lite. The lesson is over. Thank you for your attention.